This season of Threshold is underwritten by the Pulitzer Center on Crisis Reporting.
Hello there.
Hey, how are ya?
Good, how are you doing?
I'm good. Thanks for being game.
Yes, of course.
Welcome to Threshold. I'm Amy Martin, and this is Travis Yost. He makes the music for our show, including this music. I called Travis up randomly and asked if we could have a quick conversation on tape. I told him I wanted to ask him 3 questions, but I didn't tell him what they were, and I didn't tell him that the answers contain crucial information for understanding climate change in the Arctic. First of all, will you verify for me that you have no idea what I'm talking to you about? I didn't give you any warning here.
Wait, I can verify that I have no idea what you're talking about. Sure.
Okay. What is carbon? What do you think carbon is?
Carbon is the basis of everything.
Nice.
Everything has carbon. Everything is carbon-based. That is a life form, I believe. Hence the phrase carbon-based life form.
Awesome. And would we find carbon on the periodic chart anywhere?
Oh, I don't think you do.
Okay, you do.
Damn it.
Yeah, it's in there. It's just a C. It's a C.
Okay.
But the first part, what you said, is exactly right. So is there a fixed amount of carbon on the planet, or can the amount of carbon on the planet grow and shrink over time?
I don't think it's fixed. I think if it's fixed, it's got to have something to do with, like carbon dating something is a reduction in carbon from an object or something. So it's carbon that's leaving whatever object. So a fixed amount seems, if I had to guess on Jeopardy, a fixed amount seems wrong. But that would also seem really cool that there's a fixed amount of carbon and it's just being rearranged into everything else. But I'm going to go with reduction.
Oh, you were so close.
So close.
There is a fixed amount, and it is getting rearranged into different things.
Oh, yes! Awesome. I love that kind of stuff. Okay, I love that.
Yeah, carbon, it's like carbon has a cycle, just like the water cycle, but except for it's not just like the water cycle, because the water cycle is much easier to understand. It's a lot simpler. But carbon, basically, yeah, we have a fixed amount of carbon, and it moves around the planet over long periods of time, taking different forms. Like it can be in a rock, it can be in you, it can be in what you ate, it can be in the air, it can be in the ocean, but it's a fixed amount, and it's all just getting transformed into one form or another over time. Isn't that cool?
Yes, that is awesome. I like that. I like when science is kind of cute.
After spending 2 episodes with the people of Shishmaref, Alaska, we're now switching gears. We're going to far northern Sweden to hang out with some Arctic researchers. But before we head out, I wanted to get these basic facts about carbon out on the table. First, carbon is a key ingredient for organic life. In fact, it's kind of built into the definition of organic life. Organic chemistry is carbon chemistry. And second, carbon moves in a cycle. I think this is something that gets missed a lot when we talk about the amount of carbon dioxide ticking up in the atmosphere. It's not that our human activities are creating carbon. We're not making more of this stuff. What we're doing is moving it around. We're taking it from places where it's been sort of locked away, like below the Earth's crust, and then burning it, which moves a bunch of it into the atmosphere and the oceans. In April of 2018, there was an average concentration of 410 parts per million of carbon dioxide in the atmosphere. That's more carbon in the air than the Earth has seen for at least 800,000 years, maybe longer. So, who cares? Carbon moves around, sometimes it's below the Earth's crust, sometimes it's up in the air. Why is the amount of carbon in the atmosphere something people get so worked up about? Well, the crux of the issue is this. When carbon is buried underground, it doesn't affect us all that much. But when it's hanging out in the atmosphere, it warms up the climate. And this is where the Arctic comes in, because one of those places where a lot of carbon has been in a sort of resting state for a really long time is in the frozen soils of the polar north.
This frozen soil that we're sitting on is important. And what happens here should be of concern to everyone, no matter where they live.
This is Geisha Blumaveri, and she says this relationship between carbon and frozen soil is actually more of a menage a trois. There's an interloper here, a third party with powers far beyond its size. And we're going to expose all of the seamy undersides of this love triangle on this episode of Threshold.
It's very easy to think, okay, this ground is frozen and this is the way it is. But obviously that is changing.
The reason we worry is because we don't know, I think, and that's why we're here and that's why we're measuring.
We might tip the scales of these really large exchanges. Small increases in them can have a really big effect.
It takes a long time to undo what we've done.
It's all about us making an active choice now to actually do something about it.
I'm in a grassy meadow in the mountains of northern Sweden, watching Geisha Blumaveri stab the soil with a long metal pole.
It's called a permafrost probe. So this is a steel rod. So this gives us an indication of how much of the soil is frozen or not frozen.
Geisha's from Germany. She's an ecosystem ecologist, and she's been researching Arctic plants here in Abisko, Sweden for the last 6 years. She hasn't pushed the probe into the soil very far at all before it hits something. Something that sounds like a big rock.
This is not a stone. This is frozen soil.
She pulls the probe back out.
And then if you touch this,
Wow,
it's really, really cold.
that's a trip.
In just a few seconds, the end of the probe has become so cold that it's uncomfortable to touch. It's almost eerie, like it picked up a message for us from a hidden world right under our feet. The secret world of permafrost. The official definition of permafrost is just soil that's been frozen all year round for 2 years or more. But in many parts of the Arctic, it's been frozen since the last ice age. And there's a lot of variety in permafrost. It can be anywhere from a meter to a kilometer thick. It can be very, very cold or just barely frozen. And in different places all around the Arctic, it's starting to thaw. You don't actually need a permafrost probe to see it. Roads are sinking and buckling, homes are shifting and cracking, and trees are tilting at awkward angles, giving rise to the label drunken forests. In fact, there's a line of telephone poles next to the meadow where Geisha and I are standing, and one of them looks a little drunken too.
That one that is kind of tilting now, that is probably standing in an area where the permafrost is just disappearing now, so they will have to redo that soon.
All across the Arctic, communities are spending huge amounts of time and money trying to figure out how to live in this new reality, where the ground is truly shifting beneath our feet. It's not just homes and other buildings. Thawing permafrost affects all aspects of infrastructure, water mains, sewage drains, even the graves of human beings laid to rest. So we should care about permafrost if we care about Arctic people being able to meet their basic needs. But it doesn't end there. Geisha says permafrost is actually helping all of us meet our needs, no matter where we live. It's providing a globally important service, thousands of years of carbon storage, free of charge.
So the permafrost that we have here was formed probably during the last ice age, so like 11,000 years or so ago. And that material in the permafrost is that old. Like it is made up out of plant material from plants that used to grow at that time.
If you didn't know what you were looking for, you wouldn't necessarily know there was permafrost under this meadow. I'm just looking at tall green grass and little clutches of white Arctic cottonflower blowing in the breeze. But if we were to drill down into the soil below our feet and cut a chunk of the permafrost out, we would be holding an actual 11,000-year-old block of dirt containing remnants of whatever was alive here at that time.
Mainly dead plants. Sometimes also maybe the occasional dead animal like a mammoth.
Not fossilized bones or petrified wood, the actual stuff in its original state. And this is weird. Usually organic material this old would be completely decomposed after so long. So why isn't it here?
Like if you imagine you have your food standing like in the kitchen during the summer, it will go bad really quickly. And then if you take food and put it in the fridge, it takes obviously a lot longer. And if you put it in the freezer, I mean, you can have it there for years and years and it doesn't go bad. And the same thing happens here.
We've put our carbon in the freezer.
Yeah, we have. And now we are unfortunately kind of taking the plug out of the freezer and it's starting to thaw. So that's why a lot of people are interested in working with permafrost, because we think there's so much of this carbon that has been stored away, put away like in this freezer for years and years and years and years. And now within a very, very small period of time, like within a few decades, we actually have this thawing of the permafrost and this releasing of carbon.
And so then once permafrost starts to truly thaw, then carbon just kind of comes, like, how does the carbon get from down there to up into the atmosphere?
Because microbes are eating it and they are respiring, so they are breathing basically, and then they emit carbon.
So it's microbe breath that we have to worry about.
Yeah, basically.
Damn microbes.
And cow farts, that I think are the worst things.
Microbes. They are the third party in this drama. When living things die, microbes are the ones that do the work of breaking things down. They basically operate tiny little chemistry labs that unlock the carbon in a blade of grass or the horn of a bison. And like Geisha said, when they do that, they respire carbon dioxide. I'm going to continue to call it microbe breath, even though most of these tiny little organisms don't actually have mouths, let alone lungs. The point is, their work puts more carbon dioxide into the atmosphere. Freezing slows them down, thawing speeds them back up. And Geisha says in many parts of the Arctic, the permafrost is right on the cusp of that pivot point between frozen and thawed.
If you have a warming of 1 degree, that makes all the difference in the world, because it gets from frozen to thawed. And that is something that us scientists are really worried about, because there are many thresholds that you might cross there.
Thank you for referencing my show. Sorry to be so self-referential here, but this concept of thresholds really does come up over and over when you talk to scientists in the Arctic. And that's just because of the nature of how things freeze and thaw. When something is really, really cold, a temperature change of 1 or 2 degrees might not have an obvious effect. But when something is teetering between a frozen and an unfrozen state, a 1 degree temperature change can trigger a radical transformation. It can flip permafrost soil from being something that stores carbon to something that emits it.
If these numbers just change a little bit, then it can have really dramatic consequences.
And that's because as soon as the soil thaws out, microbes are ready to go to town, breaking down that frozen dead stuff and breathing out planet-warming gases. But how much does this microbe breath really matter? Like, how much carbon is there in Arctic soil?
The amount of carbon that's stored in here it's twice the amount that we have in the atmosphere. And so if that would all be released into the atmosphere, that would mean a huge climatic change for sure.
This is Joachim Janssen. He's from the Netherlands, and like Geisha, he's studying permafrost here in northern Sweden.
When you say the amount of carbon we have stored here is twice what's in the atmosphere, you mean the amount of carbon we have in the Arctic?
Yeah, just in Arctic permafrost.
Just in Arctic permafrost?
Permafrost soils, yeah.
Whoa. That's twice what's in the atmosphere right now?
Yeah.
Wow. Okay.
This is a statistic worth remembering, so I'm going to say it again another way. Take all the carbon currently floating around in the atmosphere and put it in one bucket. Then scoop up all of the carbon currently frozen in Arctic permafrost, and it would fill 2 buckets of the same size. Atmospheric carbon, permafrost carbon. I'm using that alarming sound effect because this is alarming. Usually when we talk about carbon emissions, we're picturing the exhaust from tailpipes or soot spewing out of smokestacks. But here in this beautiful little Swedish meadow, there's all kinds of carbon just waiting to be released. In fact, our human-caused emissions, big as they are, would be dwarfed by all the carbon stored in Arctic soil.
We might tip the scales of these really large exchanges that have as such nothing to do with us. But because they are so large, small increases in them can have a really big effect.
And there's more. This giant reservoir of greenhouse gases stored in Arctic soils, it hasn't yet been factored into the models that we're using to set global climate policy, meaning the Paris Agreement. Carbon emissions from thawing permafrost soil aren't factored into that, which means the goals set in that agreement may not go nearly far enough. Like, we might be aiming to reduce our carbon emissions by X%, but once we factor in the carbon coming out of the permafrost, it may turn out that we need to reduce our emissions by X% times 10, or 5, or 20. So why aren't permafrost emissions part of the Paris Agreement? To answer that question, we're going to take a boat ride, right after this short break. Welcome back to Threshold. I'm Amy Martin, and I'm out on the lake with 3 scientists, just down the road from the meadow where I was talking with Geisha. It's a lovely summer day, there are flocks of birds circling around us in the sky, and I'm just sitting in the middle of a rowboat, like a tourist in Venice.
Who knew that climate change research could be so much fun?
We have so much fun on the boat when me and Jenny go out.
That's Matilda Niesel. She and Jenny Goling trade off doing the rowing. They're master's students at Stockholm University, working as field assistants on this project, which is led by Joachim Janssen, who's getting his PhD. So, a quick reminder of what we know so far. Permafrost is frozen soil. It's storing a lot of carbon, twice as much as what's currently in the atmosphere. And as we warm the planet, we risk setting off a sort of chain reaction in which our emissions cause these natural emissions to accelerate, which leads to yet more warming, which leads to more emissions, and on and on. And we learned permafrost emissions aren't yet included in the Paris Agreement, which is an international effort to limit global temperature rise to less than 2 degrees Celsius over pre-industrial levels. Almost every country in the world, other than the United States, intends to honor that agreement. And although many believe it doesn't go nearly far enough, it has been heralded as a breakthrough in global climate policy. But carbon emissions from frozen soils have not been factored into it. So the question is, why not? To answer that, we're going to try to wrap our heads around this one project on this one lake in this one country. Here's Joachim explaining what this project is all about.
We are looking at the methane gas bubbling from the lake sediment into the atmosphere.
Methane is just another carbon-based gas produced by microbes. It's actually a much more potent brand of microbe breath than carbon dioxide. It does a much better job of trapping heat in the atmosphere for a short time, but then it decays into carbon dioxide after a decade or two. The microbes that produce methane are called methanogens.
Right, so the reason we have a lot of methane here is because this is a very organic-rich area. In the lake, we have a lot of organics washing in from the land, and this is the material that the methanogens, the bacteria, they need.
So, in this ménage-à-trois between carbon, microbes, and frozen soil, methanogens are the microbes that show up in wet places. We're talking about the insides of cow stomachs and in sediments at the bottoms of lakes. Since the thawing of permafrost is making the Arctic wetter, that means more habitat for methanogens, which means more methane, more of this powerful climate-warming gas. But how much more? Well, that's what this team is trying to figure out. Their mission is to capture and measure this particular brand of microbreath.
And in order to do that, we have a whole number, 40 in total, of these inverted funnels, and they float on the water.
Picture a big funnel, like you would use if you needed to pour gas into your car from a can. Matilda rows us up close to one of them, turned upside down, floating in the lake. It has a big syringe fitted onto the skinny end, which in this case is the top. These little contraptions look pretty homemade, because they are.
The way we make them float is by using pool noodles, things you would use in a swimming pool. So we got a whole box of those. It's kind of weird when you buy them.
So, you take your plastic funnel, turn it upside down, wrap a piece of pool noodle around the wide part, and put a plastic syringe on the top. And you've got yourself a little trap, designed to capture
any ebullition from the bottom sediment.
Any what from the?
Bubbles, basically ebullition.
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 I love it. When scientists want to say bubbles, it's not a bubble, it's an ebullition. Okay.
I was saying it wrong, actually. It's ebullition, not ebullition. But anyway, bubbles. Microbe breath.
And the methane bubble gets in, and we have a tap at the top that we can open up, and then we can sample the gas with a syringe. And then we take that syringe to the lab, and then we measure the methane concentration.
Matilda expertly rows us up to another trap, and Joachim reaches over the side of the boat with a syringe in his hand.
So he's pulling out the gas.
What'd you find there?
So we emptied the bubble trap of gas, and we had about 7 milliliters of gas. So this used to be in the lake sediment, where it formed a bubble, and that bubble traveled through the water into our trap, and now it's in the syringe.
They've likely captured a mixture of gases.
Most of which will likely be methane, but we're not sure, so we take these to the lab and then we measure the actual methane concentration.
They have 40 of these bubble traps on this lake, a bunch more on another lake, and they check all of these traps multiple times a week, all summer long. This is the nitty-gritty of science, making the instruments you need, collecting your data bit by tiny bit, carefully recording your findings. And this is all just to understand how much methane is coming off this one small area this year under these particular conditions. And Joachim says the more we learn about communities of microbes, the more we realize how complex they really are.
Those communities will change. Like, it will be above water at one point, and then it thaws out, and then suddenly it will be underwater. And then different microbes will be there that can eat different types of carbon. And then the water starts to move and start to transport carbon away. And so it's all very complex. It's a complex system.
And he's just talking about the complexity here at this study site. Groups of scientists are at work around the Arctic, studying sites that are wetter or drier, colder or warmer, with more or less vegetation.
What makes it complicated is the heterogeneity of it, so the diversity of landscapes and microbial life that we're dealing with.
So how old is the carbon these microbes are eating? Like, are they chomping on dead plants from 200 years ago or 20,000 years ago? And how quickly are they eating it? And once we understand what's going on in this one particular study site, which is clearly no small task in itself, how do we combine that knowledge with information from all the other sites to really accurately predict carbon emissions from thawing permafrost overall? The answer to all of these questions is the same. We don't really know yet.
The reason we worry is because we don't know, I think, and that's why we're here and that's why we're measuring.
This is why we haven't included carbon emissions from frozen soil in the Paris Agreement. Calculating this stuff is really complex. And we've never warmed the planet up like we're doing now. The last time there was this much carbon in the atmosphere was before humans walked the Earth. So, at least from our species' perspective, we're in what's called a no analog situation.
There's like this big machine that we're operating that we don't know anything about.
Scientists are working feverishly all around the Arctic, trying to figure all these things out so we can start to update our models and our climate policies.
I think the scary part is that we don't know what an extra 4 degrees of warming will do to this huge amount of carbon that's stored here in the permafrost.
But mixed in with all of these unknowns, there are some things we do definitely understand. I try to repeat back what I've learned to Joachim to see if I've got my facts straight.
In really broad terms, there's 2 ways to heat up the planet. There's things that humans do, and there's things that the Earth naturally does on its own.
Yep.
And these 2 things do not operate in isolation from one another. The way that the humans are heating up the planet can affect the way the natural systems work. Is that right?
That's exactly right. Yeah. So by warming up the planet, and especially the Arctic, we accelerate natural processes that already naturally release greenhouse gases into the atmosphere. That's a process that's already happening, but by further warming the Arctic climate, that process is going to accelerate.
We don't know how close we are to a massive release of carbon from frozen Arctic soils, but we do know that every bit of carbon we emit into the atmosphere gets us closer to that point. And we also know that we don't get a second chance at this. Once our emissions trigger this much larger release of carbon, we've put ourselves at the mercy of processes that will dramatically reshape the Earth's climate and our own civilizations. That's why Joachim believes caution is in order.
There's a knob that we turn on that big Arctic permafrost machine that we don't know what it does. And until we actually figure out what it does, it may be a good idea to stop turning the knob.
I asked him if he thought it was still worth it to try to stop turning the knob. Like, is it already too late? Has the damage been done?
No, we have an ability to say stop. I mean, of course we do. We have choices. I think especially in the Western world, in the rich world, we have choices, and therefore we have a responsibility. And one of the ways is to try and understand this experiment better, and that's my part. That's what we do here. And the other part is acting on what we already know, which is stop putting so much greenhouse gases in the atmosphere. I think we have a responsibility, and I think we can act. Absolutely.
It's not about saving the polar bear.
Geisha Blumaveri.
I think a lot of people, when they think about climate change, they're like, some plants will disappear, and the polar bear, it's cute, but it's also about like us surviving as a species, because if it gets much warmer, like the way that we have evolved with our agriculture and how we, like the food that we eat and where we live, is just not adapted to that. Yeah, it's just not.
I mean, it sounds really scary. How scared are you?
Sometimes I get really scared. If I really, really think about it, I get freaked out. Seriously freaked out. But then I'm like, okay, but you also have to, you cannot spend your life in being freaked out.
Getting scared as we learn about this stuff is totally normal. It's what we do with that fear that matters.
It never helps to put your head in the sand, right? I mean, it never helps to just stop functioning because you are too scared of something. I mean, that is a very bad strategy in general. So I don't think we should do that.
When we hear scientists talk about 1 or 2 or 3 degrees of warming, it might not sound like a big deal. But the additional carbon that we're adding to the atmosphere is like kindling that could ignite a much more powerful fire. We're sparking a dangerously heated love triangle between carbon, permafrost, and microbes. They've got their own thing going on. They very literally have their own chemistry. And if we don't respect that, there will be consequences. We have to figure out how to place some limits on ourselves, or a network of microscopic beings is ready to impose the limits on us. It's humbling. Maybe that's why we're having such a hard time wrapping our heads around the realities of climate change.
Do you think that we can do it? Like, do you think that in 5,000 years we're going to look back and be like, that was the point when humans started their path toward extinction? Or do you think we're going to look back and be like, that was the point where we started to grow up and we shifted into a different kind of way of living?
I really, 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 really wish that it's the point where we shifted. I don't know. Yeah, I really hope so.
This season of Threshold was produced in partnership with Montana Public Radio and PRI's The World, and with support from the Pulitzer Center on Crisis Reporting, the Park Foundation, and you, our listeners. We want to keep in touch with you. Join our mailing list at thresholdpodcast.org.
Threshold is created by Nick Mott, Rachel Kramer, Cheryl Skibicki, and me, Amy Martin, with help from Frank Allen, Jackson Barnett, Josh Burnham, Maxine Spire, Michael Connor, Matt Hurley, Nora Sachs, Rachel Klein, Rosie Costin, Zach Wilson, and Zoe Rome. Special thanks to Tom Douglas, Tom Evans, Cindy Gilbert, Michael Gundale, Keith Larson, Sylvan Monteau, Michael San Clements, Kevin Schaefer, Sarah Strand, and Hannah Rosenzweig. Our music is by Travis Yost. And in our next episode,
the sun goes down and it stays down.
Why did humans ever come to live in the Arctic in the first place?
It's all dark for months.
That's next time on Threshold.